Hello, my name is Steve Crown. Let's see what we got for projects. Let's see here. Now, I've been having issues with values did not get saved. Okay. So what is this? This is the command module. This is the airlock system. This is the pilot cockpit area. There we go. Come on. Okay, I can't rotate this camera. Okay, so what we're going to have to do well, our naming is down here now. Okay. Command module. Now, what I've been wanting to do with the command module is have it look like the Apollo command module, which has the angle down here, but every time I tried to modify the module, like getting rid of the sides and then stretching this out, it does not, that structure does not get saved, and this gets replaced. If it does get saved, but I exit it, then when I come back in, this is here instead of the redesign. So I'm just going to let it go at that. Now, let's see here. Command module. Rotate it. Okay, command module, which is locations. Okay. I moved to the Z position for modifying it, and it did not stick. So we're going to move back to 0. And then we're going to move it up 200. $200 is the main spacecraft assembly. And okay. Move it back to 0. Move it up to 200. Okay. Okay. That is the. Move it to 5. Nope. Minus 2.5. Yeah. Make it transparent. Okay, let's just redo from that from scratch. Okay. New model. So we got three astronauts. Basic volume is 4 feet per astronaut, so that's 12 feet, and that's going to be in the Z range. And eight feet standing up. We have a desk, so that's going to be, so scale that, oops, that's going to be 8 feet high. And then because the desk area, the chair would be a seating position, and then you have the space behind the chair to enter and exit the chair. So that's going to be another 4 feet, so that's 8 feet in the X dimension. Here's a transparent version of that. Save that. Let's just leave it there for the time being. Okay. Create a new. Okay, so scale that. Well, this is the cockpit frame volume. Don't know if we actually need it at this time, but I'm going to put it in there just in, for the protocols. May have it, may not have it. There may be more space available on the sides, whatever. But right now, I'm just going to do the frame structure just for protocols. So the frame structure is 1 foot thick. That means 12 plus 2 are left and right, so that's 14 on the z-axis. And 8 plus 2 is on the y-axis for 10. And 8 for 2 on the x-axis is 10. material, transparency 0.5, and then we move it to 200. And we save that. Cockpit frame volume, crew seating. Okay. Move it. Minus 10. Oops, wrong 10. Five. Okay, so it's there. And then go there. It's okay. Now we need to go up. Let's go this way. Okay, go to 210 or 8. That's good. So proceeding. X5, oops, 5. And that's 08 to 08. I did two objects. No. I don't know how it's going to do. It's been a few weeks, a week or two since I used Prisma3D. So it's been like a week or two, maybe 3, since I made my last PRISMA3D video. There may have been an update since then that would change some of this BS. Maybe. But I'm not going to test it right now. I'm not in a good mood. Okay. Okay, I'm going to create a new model. Sphere. Habitation Module. Frame volume. I got that. Skillet. 31 feet in diameter. I said 31. That's length. That's diameter. So 8 times 3 is 24. Plus 4 is 28 feet. Is our material, transparency, rotate it, 90, move it to 100. Okay, just get all this, save that. Okay, let's see here. Let's move it. 14, negative 14. Oh, what I can do. Okay, I'm going to rename it. Command module exterior. We're going to rename that exterior. Okay, just get all that. Okay, we're just going to rename stuff here. Airlock, exterior. This goes back to what I was doing in earlier editions of the PRISMA3D that got erased. Let's be anal and just exit. Yeah, I got some orange. I'm eating some tangerines. I need a better recording area. Okay, so that's airlock interior, airlock exterior. Okay, then I can do framework and things won't get confusing because I'm going to have to do, when I do frame structures, I'm going to use the term frame. So crew seating is going to be changed to cockpit interior. Exit that because I'm just being anal right now. I really don't care. I'm just, like I said, I'm not in a good mood. So I'm just going ultra simple. And with the way PRISMA3D has been acting up recently on the stuff with the new upgrade, yeah, I just, whatever. Cockpit exterior. Rotation monitor. Basic human volume, basic spacecraft volume, okay. Airlock interior. Now what I could do, I'm thinking about the command module design. Okay. Do that, get out of that. Like that. Okay, I like that show. That's good so he knows if it's hidden or not. But you can tell if it's hidden or not. So, but this is, yeah, that's a good, proper way of doing things. Instead of keeping it hidden and saying hide and then, so yeah, this is good. So basically what I'm thinking about is redoing the command module and widening this section up for 1 foot, because the the airlock, you want another foot around the airlock so that you have the airlock connect to the frame structure of the command module, and then you have the airlock frame structure. Then you have the command module frame structure that goes beyond the airlock frame structure. I'm thinking about that, and I think I want to do that. Show it. So, okay. 14 feet. From here to the middle of that is 14 feet. About another 10 feet, so that's 24 feet. No. Wait. Another 14 feet. So that's 38 feet. Yeah, okay. So yeah, the command module was 30 feet in diameter. Due to the placement of the cockpit and the airlock. $28 plus 10 is 38. I'm going to raise the, okay. Save this change. I do not have paperwork on this, not making any plans and AFK notes or anything. I'm just doing this off the fly in real time. Basically, it's I'm drawing this on a piece of paper right now. This is equivalent to what I'm doing on a piece of paper. What a draftsman would do for notes and sketches, and you get a couple graph paper or whatever. Basically what I'm doing here is that. I am trained as a draftsman, high school and collegiate and trade school. I am not trained as a CGI artist. So, cockpit exterior. No. Undo that. That's why you get out of now. Whatever. Okay. Cockpit exterior. We're going to move that up one. So that's 209. That looks wrong. It is wrong. Okay. To 8.5. Close enough. And so that means the cockpit interior has to go up to 8.5. And so we're going to move that 38. Minus 38 minus 5 is 33. Okay, and then we're going to move that minus 33. Save that. I don't want to do too much. So move that 28, and then another 10, that is 38. Yeah, I want to put another foot distance in there, so that's going to be 39. Airlock exterior, 39, and that's 44. Yeah, I'm watching the camera. That's why. Okay. Cockpit interior. Oh. No, wrong one. Airlock interior. Move it. Minus 44. So the command module exterior is now 31 feet in diameter and 25 feet in length. And okay, let's get out of this. So now bottom one. Having hiccups. Airlock interior, hide that. Okay, so now the frame structure is going to have to be widened also, so hide that. So okay, so when I'm making I'm going to make a new one because the values, okay, got that command module. It's 1. So if the values had stick that I created with these, which is 30 feet by 20 feet, and then 8 feet, well, 4, 6 feet, yeah. So it has to be 8 feet in diameter, this area here. I could do, well, if I could, yeah, if the value stuck, all I had to do was copy this, not copy it, go here, redo the numbers, and save it. And don't have to do anything more. But I have to delete this and create a new object, which is a pain in the rear. Just exit that. Make sure. Because I'm going to use the same name. So there you are. Now, 31 feet in diameter. Okay, so okay, habitation, everything's good. New model, cylinder, material, you do not want this here, otherwise it might actually touch this stuff. I want to rename it. So that's command module exterior. Skillet. 31. 31. 21. And then we want to remove that. To 50. So we can modify that, and we're going to make it opaque. So bad things don't happen when you're messing with things. New material. That'll work. Wait, let's see if I can change this. Nope. Nope. Okay, we're going to create a new cylinder. Oops. To 1.1. 8. For the human volume, it has 4 feet in diameter. Then framework adds 2 for the airlock interior. So airlock framework is another foot thick, so that's 6 feet. And then the spacecraft frame structure is a foot thick, so that's another 2 feet, that's 8 feet. Now we move it to 50. Okay. You go to command module exterior, model that. Skillet. That's good as gonna get. Okay. Delete the cylinder. Get out of there. Okay. Okay, command module, everything's good. Rotate it 90. Move it 0 to 100. Minus 28. Okay, 28.5. minus 38.5. And airlock on show it. I'm just saying unhide. Show it. And then just save that. Multi-motor engine spacecraft design. So, okay. This is a variation of the Apollo CSM LM spacecraft. So this is basically a Flower Child series spacecraft design. A variation of the the Flower Child series is a static model program, and basically the idea is here are some designs and put some components in here, and it's a proof of concept as far as technologies, how we can put the technologies together and stuff. And so it's a static model. These are prototype. That's what the Flower Child series does. And then you want to put in an Earth orbit. It's so it's a static model for Earth orbital spacecraft designs, and static model for lunar orbit, translunar spacecraft designs, and lunar orbital spacecraft designs. Earth, Mars, interplanetary spacecraft designs. Static model. So that's what the Flower Child does. That's what the Flower Child series is about. It's just a static model. It's just a proof of concept by but the original Flower Child's concept is to, modifying the Apollo CSM LM spacecraft design for an orbit-to-orbit only Earth, Luna, translunar spacecraft design. It's not designed to. It's just designed to go from Earth's orbit to lunar orbit and stays in lunar orbit, then go back to Earth. Stays in lunar orbit for X amount of days, X amount of months, X amount of years, then go back to Earth. And then you can do various. Now, if you wanted to land on the moon, you have to create a lunar module that the Flower Child series has to carry to the moon, and then the lunar module will land on the moon and then launch from the way the Apollo was. But unlike the Apollo CSM LM, the Flower Child spacecraft is not capable of doing that. The lunar module is replaced by a habitation module for allowing longer duration lunar missions in lunar orbit. And as a science research and exploration platform for developing Earth, Mars, and interplanetary spacecraft designs. Manned spacecraft designs. Proof of concept, protocols, and stuff like that. So, that's the theory behind the Flower Child series spacecraft design. Okay, and delete. Command module exterior, habitation module exterior. I do not have an interior. Okay, I need to make deck areas, deck volumes for the habitation module. Okay, let's look at the command module. That's okay. Get all that. Okay, the window did not get saved. Okay, well, let's verify that. Command module, material. Yeah. I tried to create a window and the window did not stick. Okay. So I do not know how to deal with that. Now with Blender 3D, but then Blender 3D is a PC for desktop and laptop computer systems and not for mobile devices like this tablet or smartphones. It has big space and you can add lines. So what I did was I had a section and I just knocked that out and then I create a duplicate and then reverse the process of eliminating the thing. And so I had windows and so I copied windows within the command modules. Okay, I need to get something to drink. But, you know, this is PRISMA3D is a tablet application, so it's not going to be as powerful as something like Blender 3D. Expecting to have the same capabilities as Blender is unrealistic. So that, change material to that, and let's exit. Okay. So now we're going to make some deck spaces for the habitation module. There we are. Okay. Only got about 3 hours to play with on the smartphone now. I put some stuff on the smartphone, so I don't have a 4-hour recording time anymore. So I need to watch my timing. Let's see here. There's that. Okay, this is where the habitation module location is. 200 at -14. New model. Here's the name of deck right now. Material that. Transparency. Skillet. 8 feet high. Basic interior volume for astronauts. And since the habitation module is 31 feet in diameter on the exterior, frame structure is 1 feet, the interior volume is 29 feet. Rotate it 90. Move it 200. -14. Yeah, there. Save that. Everything looks good. Everything's good there. Copy the deck. Copy the deck. Okay. Let's see here. Then we move it. 8 plus 1 is 9. That's 23. I said 23. Deck. Copy that. Move it -9. That's not -5. Okay, so now this is we named it as the privacy deck. These are where the crew quarters are. Bathing and where they bathe and sleep. Each crew member has a section devoted to himself. So basically for 3 crew members, based on the Apollo program, you'll have 1, 2, 3 guys and a bathing area, a toilet area, toilet bathing area, and then you have personal space. Then the rest is there is a you can do with this deck. You could have so accessing this deck would be theoretically through the center, and then you have doorways on to go to each area to represent that. You would have a now this is the mission deck. I'll worry about that better. I need to ring that as the mission deck. This is where they do the not fact deck. This is where they do the scientific labs, the scientific experiments. For example, on the Apollo missions, the scientific equipment would be stored here that they put onto the moon for the seismic tests and stuff. The rocks that they collected from the lunar surface would be stored in this area. That's what the mission deck would be like. That's the purpose of the mission deck. And then the common area deck, or the common deck, rename that. That is where they eat, socialize, recreate, exercise. You have your exercise equipment, you have your eating stations there. So ideally, for a common deck, I'm just going to see what goes on here. Everything's good visually. That's good. Okay, that's good. And that's good. For the common area deck and what I would prefer when it comes to astronauts traveling between decks is I would have what I call a Crawlspace Tunnel. New model, cube, and let's see here. So 24, 25, 26 feet, skillet. X is 26. And then 4 feet. And then 4 feet. Come on. Okay. Cube. Material. Transparency. Okay, rename that Crawlspace Interior. So let's go with 200. I'll go with minus 14. Then go to 200. So that would be what it would look like if it's all the way, if you had an interior space, which is what they do for the International Space Station. That's how all the modules are connected. You have a Crawlspace interior that goes in between the decks and the center of the deck. what I prefer for the fragile spacecraft is the crawl space to be on the edge of the structure. But okay, we're going to knock it downwards. Actually, what I should do is resize it. So we have 10 feet here. Ooh. And we are at 233. Or is it 239? No, 235. I got my screen. My smartphone screen is broke. So the number. Come on. Where are you? Maybe this is going to be a good time to stop. Yeah, I'm ending it right now.